Hello, everyone. Welcome to today's webcast on the powerful pairing of Databricks and Tableau. To introduce myself quickly, my name is Robbie Shaw. I'm a BI and Analytics consultant with Thorogood, and I'm part of our UK Databricks team. I've been involved in multiple projects utilizing both Databricks and Tableau, and I'm also presenting from home today, so please bear with me in case of any connectivity or any sound issues or anything like that. Let's start with our agenda today. We'll briefly introduce Thorogood and both of the tools in this powerful pairing. Then we'll move on to the pairing itself, demonstrating the Tableau-native connector to get data from Databricks. Next, we will cover how this connector allows for a different data architecture, and then using this alternate architecture, we'll demo a use case example. Then we'll wrap up with slides on how we can facilitate you to integrate this pairing to your organization. For those of you not familiar with us, Thorogood is an independent business intelligence and analytics consultancy with operations in the UK, the US, India, Brazil, and Singapore. Our core business is the design and development of business intelligence and analytics applications, but we also provide a full range of services, including strategies and roadmaps, training and user adoption, and support and data services. We keep customers at the core of our business, and we do this by A, putting our clients first, and maintaining the focus on their business in everything we do, and B, unlocking the business possibilities by combining that customer focus with the most modern cutting-edge technologies. Through this, we can unlock the analytic opportunities and provide real business value. We stay on the forefront of the technical possibilities through our partnerships with the companies that are providing world-leading business intelligence and analytics tools. To the context of this webcast, we partner with both Databricks and Tableau, and our partnerships with both AWS and Microsoft, the providers of Azure, are also relevant to this topic as Databricks requires cloud capability. Now, to familiarize ourselves with Databricks, Databricks is a market leader in both data engineering and data science within the cloud ecosystem. It enables data engineering and ETL at scale. With more companies moving to cloud data architecture, Databricks is offering the flexibility and capability that these businesses need. It connects to a variety of data sources and data types for input and output. There's multiple languages available to manipulate data with. The auto-scale functionality lends itself excellently to regular data loads where a lot of power is required, but only for a short amount of time. And Databricks also has great performance compared to more traditional data engineering and ETL tools. This is mainly enabled by the Spark data frame and the ability to run loads and transformations in parallel by distributing the workloads across different nodes. As I said, the second application is for data science, and again, it's flexibility that comes to the fore. It's very useful to be able to switch between languages and use many different machine learning frameworks. And additionally, the interface allows the user to display their analysis in a very readable format, as they can explain steps with text headers and divide the notebook into collapsible sections. The notebook also stores revision history and allows for multiple simultaneous users. Therefore, teammates find it a lot easier to collaborate and understand their collective progress much faster. One works in the Databricks Workspace to use its features. It's simply accessed via a web browser. Within the Databricks Workspace, we need a cluster and a notebook. The cluster is the key to the processing. It's one main computer called the driver node and several other computers called the worker nodes. The driver interprets the run commands, and the actual processing workload is then distributed across the worker nodes. Cluster is relatively easy to set up. They can differentiate by size of machines and number of machines, and you can turn the clusters on and off to manage the compute power that you're actually using up. The notebook is made up of cells of code, and each cell has its own output. The notebook can be run as a whole, with each cell running in sequence, or individual cells can be run on an ad hoc basis. To give an overview of Tableau as well, some of you may already be familiar with the Tableau product, but for those who aren't, at a high level, we have Tableau Desktop, which enables you to quickly create stunning visuals to get insight from your data. The desktop offers an on-premise tool for users to create dashboards and reports in an agile development environment while supporting self-service analysis of their data. Tableau Server is a web-based platform that allows user collaboration and sharing of data. With this tool, you have the ability to publish data sources created by users and allow for enterprise self-service analysis on the data with reports that are created in desktop. Tableau Online is an SaaS version of Tableau Server that is maintained by Tableau in the cloud. And finally, Tableau Prep is a data manipulation tool that was added to the suite last year. This new offering is a personal data preparation tool that empowers users with the ability to cleanse, merge, aggregate, and essentially prepare data for analysis in Tableau. There's many front-end BI tools out there, so why focus on Tableau? And the simple answer is that it's a leader in the space. Tableau is maintaining and even bolstering its position as a leader in the Gartner Magic Quadrant. And in August 2019, Salesforce completed its acquisition of Tableau, which will likely have a positive influence on Tableau's offering in the future. It offers an exploration experience that enables business users to access, prepare, analyze, and present findings in their data. And it has been one of the most influential tools for increasing the data savviness of users, enabling them to discover their own valuable data insights. Now, let's concentrate on the combination of both of the tools. So first up, let's look at the actual Tableau Databricks connector. The connector is titled Databricks. I don't think it took them too long to name it. It's one of many connection options when establishing a new data source in the Tableau workbook. Once selected, you fill in the relevant server host name, HTTP path, both of which you collect from the Databricks cluster. Then you can authenticate using your Databricks username and password, or alternatively, you can generate a token and use that instead. You then hit sign in and your Tableau Databricks connection is established. This was released roughly half a year ago as part of the release of Tableau 2019.3. It gives you the valuable ability to make your ETL processes more efficient by connecting directly to Databricks from Tableau. Databricks is a very hot and exciting technology right now that we see a lot of customers beginning to adopt and pick up really fast as well. So to see the in-partnership effort between Databricks and Tableau to produce such a simple connection is exciting, but also really promising looking forward as well. Now, to bring it to life, let's do a quick demo. Here we have a Databricks notebook wherein Microsoft Azure Databricks runs through how we prepped the table in Databricks database. So we established a mount to our data lake, Azure Data Lake storage, and in that mount, then we loaded the path to a CSV file called States of USA and created a data frame from that CSV file, which was a format CSV. We inferred the schema and we assumed first row as header. We then quickly checked the data frame to make sure that the data was sort of as we expected. So you can see it's just different states and then some further information around that. And then we took that data frame DF and wrote it to a table in the default schema called States of USA. And you can see it's present here in the default schema, States of USA. And then I will show how we connect to it using Tableau. So first of all, what we should also note is that the cluster is running at this time as well. So we go to our Databricks connection, and I've connected to it before, so that's why it's coming pre-filled, and I just have to give the token password and set up a connection. So then we'll just search for any schema because, as we've seen, we only have one default. Once that brings through, we will then search for States of USA. So we'll just drag it over here and create a live connection to the Databricks database. And then we'll just quickly build a visual out of that. So you can see we'll just drag in state. Just have to move myself out of the way to change the location from United Kingdom to USA. And you can see that it's currently docked, but I'd prefer a filled map. And with that, I want to look at the population of each state and have that sorted by color. So you can see the more populated the state, so California and Texas, the darker the color. And then what I'm going to also do is overlay the number of representatives on top of that. So they should be relatively proportional because representatives are dictated by the number of people in the state. We'll just switch to that and change the color to one that is readable over the color of the filled map and set to a dual axis. And there you can see what we've done is lifted a CSV file from our data lake, put it into the Databricks database by saving it as a table, and quickly created a visual that shows a population of different states plus the number of representatives. Just go back to our PowerPoint here. So now we've seen the connector in action, let's dive into how it can influence our overall cloud data architecture. So this is an example of typical cloud data lake architecture where Tableau is being used as the front-end reporting tool and Databricks is used as the data processing and transformation tool within the data lake. It's not cloud provider specific, but since Databricks is being used, it would be one of AWS or Azure. Files from an array of sources are ingested into the raw layer of the data lake. They are then moved through layers of the data lake. Databricks will be cleaning and transforming the data as it moves across these layers. And these files would most likely be CSV or Parquet. Once in the enriched layer, the data files are written to the semantic layer. And the semantic layer in this scenario is made up of multiple databases. Tableau then connects to these databases to retrieve data for front-end reporting, visuals, and insights. Just in case you want to think of the architecture in context of Azure or AWS, I provided examples here. Obviously, there are multiple approaches one can take with cloud architecture, and what is best differs from organization to organization, but this is a common design that has Databricks and Tableau as key contributors. How can the connector that we've demoed influence a cloud architecture such as the one that we've just shown? The obvious change is that the semantic layer can now be skipped as Tableau can connect directly to tables in Databricks database, obviously only when the cluster is running. This would also potentially remove the requirement for the enriched layer of the data lake because the final staging layer essentially becomes Databricks. However, there is another step we can bring in to improve this architecture. That additional step is utilizing Delta Lake. If you haven't come across it before, that's no problem because I'm about to explain what it is. But what you need to know is the addition of Delta Lake allows us to take full advantage of data lake storage while also holding on to some of the data control, structure, and reliability that a relational database allows. Plus, there's other benefits from Delta Lake itself. So you may be thinking that all sounds great, but what exactly is Delta Lake? Delta Lake was created by Databricks. It was originally only available within Databricks itself, but has since been open sourced. The creators describe it as an open source storage layer that brings ACID transactions to Apache Spark and big data workloads. In slightly plainer language, it's a cloud storage layer or format. Data is stored essentially as version parquet files, i.e. there's multiple old versions of the same file are stored, which in addition to the most current version. Plus there's an accompanying transaction log, which is called Delta log. And these files, these version parquet files are stored within cloud data storage, for example, Azure Data Lake Storage or an Amazon S3. And how does it advantage your organization? To highlight that, I'll run through some of the key features. So it allows users to work easily, multiple users to work easily on the same data set. This is because each transaction enacted on the data is sequentially recorded in the aforementioned Delta log. It's basically a Parquet file, therefore it reaps all the performance benefits of Parquet. It has strong schema control, which can help flag when incorrect data is being loaded. It allows for more efficient data commands. And next now, Delta Lake gives your data lake ACID transactions. ACID stands for atomicity, consistency, isolation, and durability. I'll not dive into these individually, but they are features of transactions that all tie together to increase data integrity. It has a feature called Audit History. This is the Showtime feature, in my opinion. It allows one to see what transactions have been completed, when they were completed, and which user ran the transaction. And tied in with Audit History is the Time Travel feature, which makes use of the fact that Delta holds version files. It allows users to select old versions of the dataset by referencing either a version number or a certain timestamp. And all these features give users high performance and better reliability, both of which benefit one's ETL process. So to tie this back to our architecture, Delta Lake provides all the performance of using Parquet files in traditional Data Lake, but with reliability and control closer to a relational database. At the Spark AI conference last autumn, Delta Lake was a hot topic, and a lot of the speakers were describing it as the best of both worlds from Data Lake and Data Warehouse. The joke line that was coming out of that was data engineers were now building what they were terming lake houses. It might not be that funny, but I think it does help describe the hybrid nature of Delta Lake. So just to summarize again, we have three positives in this architecture. One is the benefits of a flexible data lake, and the second is it's as if Tableau is still reading from a database. And finally, our ETL is more efficient from source to Tableau as we're skipping the semantic layer. So let's see this architecture in action. For the example, we'll be using Azure, but still following the general architecture structure that I've just covered. So we'll return to Databricks, but this time we'll go to a different notebook. And for this use case, Thorogood Incorporated is now a growing developer of personal care products, and we're using Databricks for competitive sales analysis. We want to compare our sales against sales of our competitors, so we've bought sales data from a third-party vendor from 2016 to 2019. The data is procured and delivered in the form of CSV files. These files contain, very importantly, measures of the value and volume sold for various brands of deodorants and antiperspirants across various channels. But these files are far from perfect, and they must be cleansed before they're ready for any kind of analysis. The files are placed in the company's Azure Data Lake storage. We've got to pick up those CSV files and then clean the data and then write it to a particular destination folder, which will actually be the enriched layer. And then from the enriched layer is where the reporting can be done by Tableau for viewing by the stakeholders. As I said, as you might expect, we're going to be using Delta Lake pretty heavily. So for the steps, we're going to set up the input and output variables using widgets. We're going to read the latest sales data file. We're going to perform cleaning and transformations on the data. And then we're going to write our final resulting data to the enriched layer. So step one, we just simply create widgets. So that's what's created up here. We're just going to use the default value that's set as we create the widget, but these values can be changed at any time, and then they'll change as variables, which are then used throughout the notebook. We read the latest sales data file, so it's in the raw layer in a folder called fact, and it's a CSV called sellout. And we're going to, again, infer the schema and use first row as header. And as we said previously, we set the format to CSV because we want to read the CSV file. We just do a quick data check just to make sure. So we're just looking at the top 5 rows to make sure it's sort of what we were expecting to come through. And then we create a temporary view out of that data frame fact sellout, which we've created by reading the CSV file. We then use that view to create a delta table. So the delta table is created, but we also give it a location, which is process path plus file name, which is essentially the process layer in our data lake plus fact sellout. And essentially what it's doing there is storing the data files there, but it'll still behave as if it's a table working within the Databricks workspace here. Additionally, there's some code where we're dropping the table and deleting previous old delta files as well, just so we can set up and move in this new data as if there was nothing there before. And now we clean and prepare the sales data. So first of all, we remove duplicates and remove nulls, and then we'll handle some key missing values. So if we look at volume sold for each month by type, and then actually visualize that data, what you can see is obviously we have clinical, deodorant, and antiperspirant, but also there's some null values coming through as well. That's clearly a bit of an issue. So let's just check the data to get the number of rows where this might be the case. So what we're doing is we're counting the number of rows in the data frame that was created from the CSV file, and then we're doing the exact same count, but where we drop any rows where there's a null in any of these key columns. And you can see that the difference then is the number of rows which have nulls in key columns, and that's 239 rows. And again, we do the same, but in this case, we're dropping any duplicate rows, and you can see there's 116 duplicate rows. So what we do is we can simply get rid of those because they're not needed. So we create our data frame to be what the data frame is in its current state, but with duplicates dropped and with nulls in key columns dropped. And then we write our new data frame fact sellout to the delta file, again, on the path where we created the original delta table. And then if we reference that delta table again, process fact sellout, you can see that those null values have disappeared and we just have deodorant, clinical, and antiperspirant. So now we're worried about, as I said at the top, the value and volume are going to be really key metrics for our analysis. So are there any rows where that value or volume is missing? And as you can see, we do a similar case where we're checking for nulls in those columns, and you can see there's 148 rows where this is the case. But unlike before, we can't delete those rows because they are still key combinations of dimensions, so different products and different channels. And if we can't have the actual data, what we are better having is our best estimate rather than just a null value. To look at how we replace those values, we're going to focus in on one certain brand. So we're going to look at just where the brand is pale. And it's very obvious here when we visualize it where those null values are coming from. There is no aerosol data in June of 2018. It doesn't seem right because there was quite a lot of aerosol being sold in months before and after. So either it's a fault in the data or a fault in the sort of data processes as coming into this point. So what we do is we are going to replace our temporary view that we already created, and we're going to read all these columns from our delta table process fact sellout. But if the volume and value are null, we're going to replace them with an average value based on sort of rows with similar dimensions. And once we do that, if we look at view fact sellout here, using the exact same visualization and SQL query that we used before, you can see that the aerosol data has been repopulated to something. It's not going to be the exact real values, but it is the average, and it gives something that is much better than just having null values in there. So we take that temporary view and we update the data frame, and then using the updated data frame, we write that out to our Delta table again, overriding the previous data. And that's our file fully cleansed and ready to go to the enriched layer. So we do the same where we're going to write it to the enriched layer. And then just to sort of get across the point of it's in the data lake, but it's also in the Databricks database. So if we just describe detail of our enriched fact sellout, so enriched fact sellout is our Delta table in the enriched layer. And you can see that its location is in the data lake, in the ADLS container, in the Tableau Databricks folder, in the enriched folder, and it's fact sellout CS and it's fact sellout. And then you can see here that the data is available in our default schema under enriched fact sellout as a table as well. So to go to Tableau, we can then create our dashboards and our sheets and our visuals out of referencing that enriched sellout table. So you can see here, if I go to our data source, what I've done is, again, establish the connection. It's the exact same way that I established it in the earlier demo that I was doing. And we've just thrown up some quick visuals around gross trend, sales trend, share by brand, a few different KPIs, and just essentially done analysis on our cleansed data set that we've created and written to the enriched layer. To go back to the Databricks table, I mentioned earlier about the sort of showtime features of audit history and time travel in Delta Lake. So we're going to take a quick look at that as well. So these capabilities, what people tend to be using them for is to just audit what changes have been made to the data, reproduce previous experiments that maybe were throwing up better results than once you've loaded in current data, and then simply data rollbacks if there's issue with current data. And you can query the older versions of the table using a timestamp or using a version number. So what we'll do here is we've shown how you would bring up audit history, so describe history of the Delta table. And you can see we created the table and then we overrode it twice. And you can then reference it by going select from process fact sellout version as of 0. So that would bring up this version. And you can see version as of 2, bring up this version. But you could also bring in, so it's 1757.39 was when the version 1 was created. If you put in 1758, that's timestamp, it would bring up version 1, and then any time after 6 o'clock, it would bring in version 2. So you can use timestamp instead of version number. And just to illustrate with the visualizations to see how the versioning works, you can see our version 0 was when we loaded in with CSV. And if we look at just the Pale brand again, you can see there was that missing data in June of 2018. But if we look at version 2, you can see that that's fixed, and version 2 is what we actually ended up writing to our enriched layer. And we can take advantage of that with Tableau as well. So what I've done here is, again, it's a very similar table. So we're just looking at Pale, months on the x-axis and sales value on the left. And you can see version 0, which I just showed in Databricks visualization. We can then toggle between different versions as well. So if I select version 2, then it references version 2 to where the update has been filled in. This is quite simply done through a custom SQL query. So you can see here what we've done is select star from our process fact sellout. Also, I'd like to mention here that it wouldn't be common practice to be pointing your end front-end reporting tool at the process layer. You would always be pointing at the enriched layer of your completely cleansed data that's ready to be reported on. But for this case, it's best in showing the data changes that we made. And you just go version as of parameters version, and then that parameter is set in the drop-down that I was selecting earlier. So to go back to our presentation, hopefully that demonstrated how Databricks and Tableau can be used effectively within the cloud. To summarize the benefits of the connector and the ability for Databricks and Tableau to work close together, the most obvious benefit is that you get to your data from Tableau closer to the time of its arrival into the data lake. You also get to leverage Databricks computing power. You get to gain reliability from Delta Lake's ACID transactions. You use a simple native connector with which you enjoy good speed of connection, and you have the ability to roll back and forward across different versions of the data. There is another level to the pairing of Databricks and Tableau that I would like to draw attention to. We've seen how one can use Databricks and Delta Lake for their data engineering processes, then explore that data in Tableau. There's a possible third stage to that can follow the exploration on Tableau. The user may notice trends or develop hypotheses about the data during their exploration, and at this point they can return to Databricks and generate or test their theories by exploiting the data science capabilities of Databricks. So we've covered quite a lot there, and we can provide further assistance. Firstly, if you have any questions, I'll put my details up at the end, and please don't hesitate to get in touch with me. We also have some next steps that we could use to help you get started. So we can assist you in identifying key use cases for both tools, either as a pairing or separately. As a pairing, we can provide a POC on said key use cases with Databricks and Tableau at the center of the solution. And separately, we can help set up cloud capability, including Databricks, and we can assist you with any Tableau report development, as well as an overall strategy and governance. And additionally, we have a rich library of past webcasts on our website's perspective section that are really worth checking out. That concludes our webcast today. I appreciate you taking the time to attend, and if you do have any questions or want a discussion on anything, do get in touch. Thank you.